Hey guys, I am going to go over the homework that you had for 3-6. It was 8 to 22 even. So I'm going to go over those problems now and then I will get your next lesson posted soon. So number 8, the directions were write a compound inequality that represents each phrase and then graph the solution. I feel like we have a lot of glare going on the whiteboard today. Alright, so number 8, write a compound inequality that represents each phrase and then graph the solution. So the phrase was the circumference of a women's basketball must be between 28.5 inches and 29 inches inclusive. So inclusive means that it can include 28.5 and 29 inches. So for number 8, you would say 28.5 is less than x is less than 29. And we need the or equals because it's inclusive. So 28.5 there we go. 28.5 is less than or equal to x is less than or equal to 29. When you graph that, remember you just have to put the numbers that you're working with. So we have 28.5 and we have 29, and then we should have closed circles, and it's an and, so it goes like that. Number 10, the directions say solve each compound inequality and then graph your solution. So number 10, the compound inequality is 5 is less than or equal to y plus 2 is less than or equal to 11. So when we go to solve this, we need to isolate the y. We're going to get rid of that 2 to do that. And this one, although it's a compound inequality, turns out to just be a one-step equation. You only had to get rid of the 2 by subtracting 2. Just remember to subtract 2 from everywhere. And we now have our solution, which is 3 is less than or equal to y is less than or equal to 9. When we graph that, we're going to put a 3 and a 9. You got to remember to put your smaller number on the left, your bigger number on the right. We're going to have 2 closed circles, and that would be our graph. Number 12 is the same kind of a problem, but we have a little more complicated equation, or inequality here, I should say. So it's -3 is less than or equal to 6 minus q over 9 is less than or equal to 3. So we have a few things that we have to get rid of to get q by itself. First thing we need to do is get rid of the 9. To do that, because this is being divided by 9, we're going to multiply everything by 9. So here we're going to get -27 is less than or equal to 6 minus q is less than or equal to 27. Now we'll subtract 6 everywhere. Here you have same signs, so you're going to add. Here we have different signs, so we just actually subtract normally. Now we have -q. We do not want -q, we want q. So what that means is we're going to have to multiply everything by -1. Remember that when we are multiplying by a negative number, we have to flip those inequalities. So we are going to end up with this. When we graph that, remember to put your negative number over here. We have closed circles again, and it's anything in between there. So if you read this way, it would be negative 21 is less than or equal to Q is less than or equal to 33. If you want to flip that all around, if that makes it easier for you to graph, that's fine. Just remember to flip your inequalities back around. So it would look like this. You'd have negative 21 is less than or equal to Q is less than or equal to 33. If that works better for you to graph it, you can do that. Just remember, if you're flipping it around, you flip your inequalities. Number 14 is next. Number 14 says, solve each inequality, graph your solution. So it's the same exact directions. I don't know why it's a different section, but because these are the ors and the other ones were the ands. So let's get to number 14. We have 5 plus m is greater than 4, or 7m is less than negative 35. So with the ors, you are going to just have those two inequalities that you're going to have to solve, and there's no getting around that. Remember that with the ors, your graph should go out so they don't overlap at all. They don't go in towards each other like the ands do, they go out. So when we solve these, we do it just like you would an inequality. And there are our solutions. I like to put or between them. And then when we go to graph it, we're going to graph, we're going to graph our two numbers. Negative 5 is smaller than negative 1, so I need to put that over here. And then, let's see, negative 1, we have 2 open circles because neither one has the or equal to. And then if you look at this, m is greater than negative 1, m is less than negative 5, and our graphs do go out like they should go. Number 16 is another one of these ors that we need to solve and then graph. Number 16 says 5z minus 3 is greater than 7, or 4z minus 6 is less than negative 10. So again, this one gets a little bit more complicated than the previous one, but you're solving you're solving two-step inequalities here. So when we do that, we get z is greater than 2 on this one, and over here we get z is less than negative 1. So then we need to graph. We'd have negative 1 and 2. They're both open circles. Z is greater than 2 would go this way, and z is less than negative 1 would go that way. So that would be your solution for number 16. Excuse me. Number 18, you are just says solve each inequality. So for number 18, we have negative 9 is less than 3m plus 6 is less than or equal to 18. So again, we're looking to isolate the m. So we're first going to get rid of that minus 6. Always remembering SADS and SPUN when you're working with these negative numbers. When we divide by 3, just remember to divide every term by 3. And there's our solution set. If we go ahead and graph this, this would be a closed circle because we have the or equal to, and this would be an open circle, and this is an and, so it's going to look like that. M is greater than -5, and M is less than or equal to 4. Number 20 is an OR inequality. So we're going to have two compound inequalities to solve here. We have 12h minus 3 is greater than or equal to 15h plus 1, or 4z minus 6 is less than -10. So there we go. When you're solving any inequality, we need to isolate those variables. So here what that means is you're going to have to combine your like terms. So we would first move all of our numbers to one side and all of our variables to the other side. You can do that in 2 steps if you want, or you can go ahead and do it in 1 step like I have. We end up with -4/3 is greater than or equal to h on that side. And we come over here, we end up with z is less than -1. So I just realized because of the z that I copied the wrong second inequality. Sorry about that. Make sure I got the first one okay. Yeah. And then our second one was actually 5 is greater than -2/10 h plus 10. Yeah, I miss you guys being able to say, hey, Mrs. Kunick, you copied that wrong. Okay, so when we solve this out, we're dividing by negative, which means we need to flip our inequality. And when I divide that, let's see, I'm going to actually do it. 5 divided by that, we get 25. It's positive because you had negative divided by negative. So now I have my 2 inequalities that are part of my solution. We have h is less than or equal to -4/3, or h is greater than 25. So when I graph that, I would have -4/3, 25. I have an open circle with my 25 because there's no or equal to, but with my -4/3, I need a closed circle because I do have the or equal to. And then our arrows go like that. So that would be number 20. And we have one more to do, number 22. For number 22, they give us a graph, and we're supposed to write a compound inequality that the graph could represent. So it looks like we have on our graph -2 and 1. At 1, we have a closed circle. At -2, we have an open circle. And we can tell that this is an or because our arrows go out. So when it is an or, you can't combine the 2 inequalities, you just have 2 separate inequalities. So we would say x is less than -2, or x is greater than or equal to 1. That would be your compound inequality. Let me go ahead and do 21 for you, because that was an and I just want you to see what that would look like. So for 21, you can see on the left, our dot is between -2 and -4, which means it would be at -3. And our other dot is at 4. They both appear to be open circles, and it's graphed this way, which means it's an and. So in this case, remember I said your inequalities are always going to be like that. They are both less than signs. So we have -3 is less than x is less than 4. Remember when you read this separately, we could read this one this way that says x is greater than -3, which it is, and x is less than 4, which it is. So that would be an and. Number 22 was an or. The and ones, you can also, if you prefer, you could separate this and say x is greater than -3 and x is less than 4. You could write it like that as well. Both are correct. I prefer this way because it's more streamlined and it's easier to solve those out when they're combined like that. It gives you less work to do because you can solve it all together. So that's it. That's the homework. If you guys have questions on any of those or any other ones that you might have tried in your book, please let me know either on our class discussion board or on our Zoom, which will be next Monday at 1:30. I will be posting another lesson this week, which will be the next section, 3-7. So look for that probably tomorrow, and I'll give you some homework to try from that. And then in our Zoom on Monday, we can talk about both 3-6 and 3-7. So I will see you guys on Monday next. Enjoy the rest of your week and have a great weekend.